Chapter 6, Lesson 2, Inverse Functions and Inverse Relations. So inverse, we're taking a look, what is the inverse of something? Okay, so let's take a look here what we can figure out. So if I just have points, I'm just given ordered pairs here, x's and y's, all I'm doing is taking these points and switching them. Y becomes x, x becomes y. Y becomes x, and switch. And switch, and there's my inverse relation here, or function, okay? Now, let's take a look at example 1. If I have the ordered pairs here, I'm going to draw this figure out. So I have 1, 3, 6, 4, 1, 2, 3, 4, and 2, negative 1. So let me draw my points. So here is my triangle, and now I need to find those inverse points. So let's make this a blue, and my new points are going to be 3, 1, 4, 6, negative 1, 2. So let's plot those. So 3, 1, 4, 6, and negative 1, 2. And again, let me connect those up. Blue points. So there's my blue points. So when you look at these, if you think back to those transformations from geometry class, this is actually getting flipped over, and we call that reflected. Now the reflection line is here. So here's my reflection line. Let me change that to a dotted line. Okay, so there's my reflection line. You can see straight across, these are straight across, these are the inverses of each other there. So that is, so when you're looking at the inverse, it's actually reflecting across that y equals x equation. Y equals x is that line. Okay. Now you can see here off to the right, function notation, inverse function notation. So that negative 1. So the inverse of f function is f of negative 1. Okay. Now to find the inverse function, we're going to switch x and y in our equations and solve for y. So let's take a look at these and work a couple problems here. So f of x is our y, so I'm going to switch those two. So I have x equals 2y minus 5, and now I'm just solving for y. So I'm going to add 5 to both sides. So I have x plus 5 equals 2y. 5's cancel. And to get y by itself, I'm going to divide everything by 2. So my f inverse, okay, so I have x plus 5 over 2 equals my y. Now, function notation, f negative 1, my inverse, x plus 5 over 2. Now I could rewrite it here. I could separate this 2 into both of those and say 1/2 x plus 5 over 2. And those are going to be the same equations. So it's just written in a different way. Okay? So if you want to separate them, you can. You don't have to. Typically, because neither one of these two fractions simplify, you typically wouldn't rewrite it that way. You keep it as one big fraction. But if they can simplify, you can sometimes separate them into two separate. Okay? So there's our first example 3. So example 3 now, again, we're doing the same thing. This y now becomes an x, y squared plus 3. So let's get this y by itself. So we're going to subtract 3. So I have x minus 3 equals y squared. Now we're looking for that inverse of a square root. So square and square root are inverses of each other. So then that leaves me with y equals square root of x minus 3. Again, we can rewrite that in function notation. So inverse function, square root of x minus 3. And we can just leave it just like that. Alright, we got one more example here. What if I have two functions and I want to know, are they inverses of each other? Okay? how can I determine that? Well, without actually calculating the inverse. So what I can do is I can plug him in to the composition form, okay? So I can take g of x, plug it in for x for f of x, okay? Solve. If I get x, I'm good. Then I try the other way. I switch it. If I get simplifies down to x, that tells me both equal x, or simplify down to x, those are going to be inverses of each other. So let's do the first one here. So we have f of g of x here. So we're taking that f function, which is 3/4 times something minus 6. Well, that's something we're plugging in is 4/3 x plus 8. Well, if I multiply this in and distribute, 3/4 times 4/3 just gives me 1x. 3/4 times 8, that becomes a positive 6. Oops, and not equals yet. So minus 6 comes down. Combine those like terms, and that just simplifies to x. So first one simplifies down to x, so we're good there. Let's try the other method now. So now I have 4/3 times something plus 8. Well, what am I plugging in? I'm plugging that f in now. So now I have 3/4 x minus 6. Again, distribute. 4/3 times 3/4, still 1x. 4/3 times negative 6 gives me a negative 8. Bring down the plus 8 again, combine those like terms, and those both equal x. They both simplify down to x, so yes, they are inverses. So that is lesson 2, inverses and functions and relations.